Not all games are dominance solvable. An example of a game that has neither dominated nor weakly dominated strategies is the so-called Battle of the Sexes game. By now you will have noticed that game theorists are very good at having catchy names for things. The backstory of the Battle of the Sexes game goes something like this. There are two players, Alice and Bob, and they are friends. They want to meet for coffee. Alice prefers to go to Costa Coffee, and Bob prefers to get his coffee from Starbucks. But above all, the most important thing for them is to go to the same place so they can actually meet. We formalize this game as follows. So Alice has two strategies, go to Costa or go to Starbucks, and Bob has two strategies as well, go to Costa or go to Starbucks. Now, the question here is, what will the outcome of this game be? Will Alice and Bob meet? And where will they meet? If we look at the game closely, we can reasonably conclude that there are two stable outcomes. One stable outcome is that both Alice and Bob go to Costa, and the other one is where they both go to Starbucks. The other two potential outcomes are not stable. If Alice goes to Costa and Bob goes to Starbucks, Alice could improve her payoff by also going to Starbucks. Alternatively, Bob could improve his payoff by also going to Costa. So both of them are quite unhappy with that particular outcome. Similar reasoning applies to the outcome in which Alice goes to Starbucks and Bob goes to Costa. I've vaguely talked about such stable outcomes before, but what does it actually mean? What is the formal definition of a stable outcome? To formalize this intuitive notion of a stable outcome, we start by defining what a best response is. Consider a game and suppose each player I chooses a strategy Si from her strategy set Si. Then for player J, the strategy Sj is the best response to the strategies of the remaining players if no other strategy gives player J a higher payoff when the strategies of the other players are unchanged. So this means that if the payoff that player J gets for the strategy profile S1 to Sn must be at least as large as the largest payoff the player could get for any of her strategies, while the strategies of the remaining players remain fixed. So we keep the strategy profile S1 to Sn, except that we switch out Sj for some other strategy X. And picking Sj should give a larger payoff, or at least as large a payoff, as any other X. And this idea of a best response now brings us to a new solution concept that is known as a pure Nash equilibrium. A pure Nash equilibrium of a game is a strategy profile in which the strategy of each player is a best response to the strategies of all the other players. So it's an outcome of the game where simultaneously all the players play a best response against all the other players. A simple way of finding the pure Nash equilibria of a game is to note down or mark all the best responses of all the players. Let's look at the Battle of the Sexes game again, and let's try this. If Bob goes to Costa, what is the best response for Alice? The best response for Alice is to go to Costa as well. This is because going to Costa in this scenario gives her a payoff of 3, but going to Starbucks would give her a payoff of 0 because she doesn't get to meet Bob. If Bob goes to Starbucks, what is the best response for Alice in that case? Well, in that case, the best response for Alice is to go to Starbucks as well. Now, for Bob, if Alice goes to Costa, what is the best response for Bob? Well, the best response for Bob is to go to Costa as well. And again, this is because this gives him a payoff of 1, whereas going to Starbucks means missing Alice and therefore getting a payoff of 0. And if Alice goes to Starbucks, Bob's best response to that is to go to Starbucks as well. Having marked all the best responses, we can now see that there are 2 outcomes of this game in which Bob plays a best response to Alice's strategy, and at the same time, Alice plays a best response to Bob's strategy. In one of these outcomes, Alice and Bob both go to Costa, and in the other, they both go to Starbucks. Clearly, we see that a game can have more than one pure Nash equilibrium. So this solution concept of pure Nash equilibria does not make a single prediction for the outcome of the game, or at least not for all games. So in this case, the solution concept only tells us that we should expect one of the 2 identified outcomes. We know that Alice and Bob will meet according to this prediction, but we cannot narrow down exactly where they will meet. They will either both go to Costa or both go to Starbucks.